Hi, my name is Valeria and my team is Elio, Rodrigo, Kevin, y Jorge Alejandro, and we're gonna present the exercise 15 and my problem is the number 1. Well, here is the exercise 15 and the mine is the number 1, so it says, two graduate rulers of 1 meter long passing beside an observer with a speed of 0.2 c and 0.7 c respectively. Determine the lengths that the observer will record. So we can see that the speed has 2. So we're gonna determine 2 lengths. In this problem, we're gonna talk about the length contraction. And the length contraction said that when the objects move to a speed that is closer to the speed of the light, they will contract. Something very important to know about depends is that relativity of simultaneous measurements can have powerful consequences when an object approximates to the speed of light. All physical measurements must explain the relative motion. And something that we have to know is as you approach the speed of the light, time will go slower and you will shrink, making it impossible to catch up. This is obviously, if you read this and you analyze it, is obviously. And they say that the speed of the light, call it c, it will impact even more. And the last thing to know is that according to the special theory of relativity, laws of physics are equal in any inertial frame of reference. So we're gonna start with the formula for this problem. The formula is actually really simple. We have the speed of light, that it has a special value, the L proper length, the L length measured in motion relativity, and the B is the relative velocity. And here is. So here is the data. Here is the 1 meter of the longer of the ruler, the 2 velocities, and the observer length. So here's the substitution of the 2 lengths, one with 0.2 of velocity and 0.7 of velocity. The one is always resting. Here is the longer of the ruler. And well, if we resume this, it's gonna be like this with the root and with the square all. Here is the square all, and here is 1 minus 0.04, and the root is gonna be like this. Here is the result. We also need the root. Here's the root. We multiply by 1, and here's the result with meters for the first length and the second length.
This is my presentation for the exercise 15 with my team members. I'm going to solve the problem H. In our problem H, it talk about a little bit of the Broglie equation. So let's introduce you about this equation and what proposed the Broglie. The Broglie proposed that all the objects have wavelength related to the amount of their movement, and that every particle has a wave nature. And the wavelength corresponding to this wave nature is given by the formula that we're going to present in the next video. We have our problem, which is find the wavelength of the Broglie for a proton. We have the mass there, and when it moves with a speed of 2 times 10 elevated to 7, and the units of speed. Now we have the equation, the Broglie equation, which is the wavelength. It's the Planck constant divided by mass times speed. And for those that don't know the value of Planck constant, we have there that is 6.626 times 10 elevated to minus 34. The Broglie equation indicates the length scale at which wave-like properties are important for the particle. Now, for solving our problem, we have here the solution. Is the wavelength is equal to our Planck constant and divided by the mass. In this case, is the mass of the proton and the speed that the problem gives us. That is 2 times 10 elevated to 7. And finally, our result is 1.98 times 10 elevated to minus 14.
Hi, this is Kevin and I'm going to explain the exercise E, which is a spaceship passes beside an observer with a speed of 0.88 c a passenger in that same spaceship records that that he delays 7 seconds crossing the cabin from one side to the other. Find the time that the observer will record for the same event. Well, in this case, in order to solve the exercise, we must use the time dilution formula, which every time the time intervals between events happening at speeds near the speeds of light are compared and measured by observers in different inertial reference frames. The concept of time dilation is used. So we have this formula. We're going to use this formula, which is the time dilution formula. And first of all, we have to get the data. We have B as 0.8 which is the speed of movement. We have 7 seconds, that it's body time at rest. We have C, which is the speed of light. It's 310 times 8. And we wanna know the body time in motion. So using this formula, we just make the substitution here. And this is gonna be our result, which it's gonna take 14 seconds and 76 milliseconds to record the event.
My problem states as follows. A blue 1 meter long graduated ruler is aboard the spaceship A, and another red 1 meter long graduated ruler is aboard the spaceship B. Suppose that spaceship A exceeds spaceship B at a speed of 0.95 c. Find the length of each of the rulers with respect to a person that travels aboard spaceship A. Here I did some drawings to help me understand the theory and how these spaceships will travel. And to understand this problem first, you must know that you can't outrun the speed of light, because at the moment you get close to the speed of light, which is 1c, you shrink and the time will go slower, so you won't be able to catch up. So in this problem, the spaceship A is coming closer, real close to the speed of light. It's at 0.95 c. So here is where the length contraction and time dilatation will come into place, but at the moment we are not worried about the time, just the length. So we need to find out how the ruler will be seen as in the frame of reference from the spaceship A. So we'll use the formula L equals L initial multiplied by the square root of 1 minus velocity squared over speed of light squared. I did my math and it came up to be 0.31 meters. This would mean that ruler A is in the same spaceship, so it will be seen the same. It will be 1 meter as it always been, but in the spaceship number V, the ruler will be 0.31 meters long. I found this topic very interesting because even though it's not something in which you have like an everyday example, it took big brains, like people who could think outside the box, like Albert Einstein or Sears, to think about these theories.
Hi, my name is Rodrigo and today I'm going to present the problem of the letter I of the exercise 15 of matter and energy of the model number 3. The problem said the wavelength of the Rayleigh of a particle is 3 by 10 raised to the power of minus 14 meters. Find the amount of moment of the particle. Well, the formula that I am going to use for this problem is the Rayleigh formula, that is this one, where lambda is wavelength, h is Planck's constant, that is 6.63 by 10 raised to the power of minus 34 joules per second, and m, that is mass, and v, that is velocity. Then we have to clear the equation. We have to change the formula to this, because in the problem they are asking for us to find the amount of movement of the particle. So we have to change like this the formula. Then we are going to resolve the problem. To resolve the problem, there is going to be like this. That is 6.63 by 10 raised to the power of minus 34 joules per second divided by 3 by 10 raised to the power of minus 14 meters. And the result is this one. The result is 2.21 by 10 power raised to the power of minus 20 kilograms by meters per second. And this is what we have to do to resolve this problem. This is the result, and it's all. Thank you.
And this is our opinion of the positive impact of funding men and women to keep pursuing physics as a topic or research and investigation. We think that our present, and with all the modernity of the world, it is necessary that both men and women know the basic principles of physics, science, and technology, because now there is so much job competition that now we need to be very well prepared for wherever it is. Even sometimes in everyday life, many seen concepts could be used. As has been seen recently, the numbers of men who decide to study careers that have things in common with physics is very high, and the number of women is lower. They should normalize in school that physics is for everyone. We are fully capable of understanding and developing everything. Women's educational progress should be celebrated, yet more work is needed to ensure the women and girls have full access to educational and employment opportunities in science, technology, engineering, and mathematics. It is very important to continue breaking with the stereotype that men are more capable in these areas than women. Attracting and retaining more women and men in these areas will maximize innovation, creativity, and competitiveness. Even spreading more information about these areas is also important for the future, because it could help young people with so much technology to discover new things every day.